Hello, hi everyone. First of all, congratulations. You have completed 2 weeks of this revision program. Now, welcome to the next week. In this week, we are going to take two important chapters, equilibrium and chemical kinetics. Equilibrium, we are going to study in two parts. First is the chemical equilibrium and second is the ionic equilibrium. So, in this video, we are going to discuss some previous year questions of chemical equilibrium. We are going to proceed in a systematic manner. First, we are going to discuss the weightage of this topic, syllabus, mind map, and then we will solve previous year questions. Okay. First, who will get benefit from this video? So, this video is for those students who knows the basics. It means they have studied the NCERT completely, right? They know the basics of the chemical equilibrium. They have NCERT level knowledge, but they are unable to solve a JEE level question somehow, right? And they have taken coaching somewhere so that you have all the formulas and all the concepts in your mind, but you don't know how to apply those concepts while solving the question. So this video is for those students. Okay. Now, how to use this video? So I have been telling you from the starting how to use this video. You have to revise the short notes, you have to write down the important information, and then you have to start solving the question. Otherwise, you cannot solve the question in less time, right? So, revision of the notes and revision of the complete concepts, that is mandatory, right? Before starting with this video. Okay, now let's discuss the weightage. So if I discuss weightage, the weightage is going to be the 4%, right? It is going to be 4%. It means every year we can say ki there is one question from this topic and the question is going to be very easy. What is the high priority topic over here? Calculation of equilibrium constant. So generally the questions are going to be from the equilibrium constant part. And we know that in equilibrium constant we have Kp, we have Kc, right? So we have two equilibrium constant, two important equilibrium constant, Kp and Kc. Okay, now let's discuss the mind map. So in chemical equilibrium, first we are going to discuss, or first you should have the knowledge about the basics, right? So basics में जैसे first of all कि physical equilibrium भी we are going to study in this chapter, ठीक है? And then curves for concentration and rate curve with respect to time. Then we have the types of chemical equilibrium, homogeneous and heterogeneous equilibrium. What is the homogeneous equilibrium? When all the reactants and products are in the same phase. That is considered to be the homogeneous equilibrium. Heterogeneous equilibrium, when all the reactants and products, or we can say when reactants and products, they are not in the same phase. So that is the part of the heterogeneous equilibrium. Then we have to study the, or you have to revise the equilibrium constant Kp and Kc. And what is the relationship between Kp and Kc? That is equal to Kp is equal to Kc RT to the power delta Ng, right? Then we have to understand how the reaction proceeds, right? Or in which direction reaction proceeds, or predicting the direction of a reaction. So how can we predict the direction of reaction? By reaction coefficient. And what is reaction coefficient? Reaction coefficient is Q. Okay, predicting the extent of reaction. So in the extent of reaction, we are going to discuss about degree of dissociation, right? Degree of dissociation. Next, we have the Le-chatilier principle. Le-chatilier principle, it means ki what is the effect, what is the effect of addition of something, addition of reactants or products on the equilibrium, right? So in Le-chatilier principle, we are going to understand the effect of concentration on equilibrium, effect of pressure and volume on the equilibrium, effect of temperature on the equilibrium, and effect of addition of inert gas. In the last, we are going to discuss, or we are going to discuss some question related to simultaneous equilibrium. So that's all we have to do, or we have to study chemical equilibrium, right? Before starting with the questions. So let's discuss the questions, right? So first I'm going to discuss the type 1 question, which is related to the basics of chemical equilibrium. In basics, you can have questions on rate. Okay, so if we have a reaction like A, B, it is in equilibrium with C and D, right? This is the generalized chemical reaction. So rate of forward reaction, it depends on the reactant. So we can say rate of forward reaction is Kf, concentration of A to the power A and concentration of B to the power B, and rate of backward reaction is Kb, concentration of C to the power C and concentration of D to the power D. So at equilibrium, what happens? Rate of forward reaction is equal to rate of backward reaction. So we can write K equilibrium is equal to Kf upon Kb, which is equal to C ka power C, D ka power D upon A ka power A and B ka power B. Okay, B ka power B. Then we have some concentration curves, rate versus time curve and concentration versus time curve. So what happens in rate, right? In rate versus time curve. Okay. So first we have rate of forward reaction. So forward reaction rate decreases, right? This is the rate of forward reaction. It decreases with time, and rate of backward reaction, it increases with time, right? It increases with time. And at equilibrium, rate of forward reaction is equal to rate of backward reaction. Okay. Then we have the curve, concentration versus time. We have the curve, concentration versus time. So what happens? Reactant concentration decreases with time. So if we have reactant concentration over here, right? So it decreases with time, and after the equilibrium, it becomes constant, or we can say at equilibrium, it becomes constant. Now similarly, product concentration, initially it is 0 and with time it increases, and once the equilibrium is achieved by the system, then concentration of product, it becomes constant. So this is the P equilibrium concentration and this is the R equilibrium concentration. So it becomes constant. So it means at this point we can say equilibrium is achieved, right? At equilibrium, concentration, it becomes constant. Okay, so we have this concepts, right? So questions are going to come on the basis of this concept. So let's do the question number 1. So question number 1 say, for the reaction this 2H2 gas plus 2NO gas, it gives N2 gas and 2H2O gas. So the observed rate expression is, so rate expression, it is given KFNO to the power 2 and H2. Now the question says the rate of backward reaction. So the rate of backward reaction depends on the products, right? It depends on the products. So if I write the rate of backward reaction, so it becomes Kb N to the power 1 and H2O to the power 2. So we have to select the correct option. So option number 1 is the correct answer. Okay. Now let's do the next question. For the equilibrium A is in equilibrium B, the variation of the rate of forward and reverse reaction with time is given by. So we know that rate at equilibrium, rate of forward reaction is equal to rate of backward reaction. And if you see the curves carefully, so we have only one option, that is 2. Because here what happened at this point, we can say rate of forward reaction is equal to rate of backward reaction. A is a rate of forward and B is a rate of backward reaction. Okay, simple questions are there, so very easy questions. Now next question, the number of correct statements involving equilibrium in physical processes from the following is. Physical processes means when there is no change in chemical composition of the substance, like melting, boiling. So these are all physical processes. Now first statement, equilibrium is possible only in a closed vessel at a given temperature. This is true. Equilibrium is only possible if the vessel is closed. If the vessel is open, then equilibrium cannot be established. So for example, if we say we have liquid water, this is H2O liquid, and I am heating this liquid water, right? So we know that liquid converts to vapor, right? Liquid converts to vapor. If the container is open, then what happens? Steam evaporates, steam goes to the atmosphere. But here what happens? If the container is closed, then what happens, we can say there is the equilibrium established in between the water in liquid state and water in gaseous state. So this statement is true. Now second, both the opposing process occur at the same rate? Yes. So we know that at equilibrium, rate of forward reaction is equal to rate of backward reaction. So this is also true. Next, when equilibrium is attained at a given temperature, the value of all its parameters became equal? No. All parameters, the value of all parameters, they will not get equal, right? They become constant. Constant hai. So it means this statement is false. Next, for dissolution of solids and liquids, solubility is constant at a given temperature. So solubility is constant for dissolution of solids in liquids. The solubility is constant at a given temperature. True. Right, at a constant temperature. Because if you increase the temperature, then solubility of solids in liquids increases, right? But if the temperature is constant, then the solubility is going to be same. So how many correct statements we have in this question? The answer is going to be 3. So we have 3 statements, or we can say 3 correct statements. Okay, so first type is over. Now we are going to discuss some questions of type 2, in which we have questions related to equilibrium constant. So we know that K equilibrium is what? Product का concentration raised to power its coefficient divided by reactant का concentration raised to power its coefficient, and it is better to write this like K equilibrium is activity of products raised to power its coefficient divided by activity of reactants raised to power its coefficient. Activity for solids and liquids, they are considered to be 1. It is considered to be 1. So in the equilibrium expression, we can take aqueous term or we can take gaseous terms. We can take only these 2 terms. Okay. So K equilibrium, it can be Kc or Kp, right? We can also have Kx and Kn, but right now we have Kc and Kp. So in Kc, we have to take concentration of products, right? Molar concentration, molarity. So here Kc is equal to concentration of product raised to power its coefficient divided by reactant concentration raised to power its coefficient, and that concentration, that should be molarity. Okay, that should be molarity. Now we have Kp. So in Kp, we have pressure of product raised to power its coefficient divided by pressure of reactant raised to power its coefficient. Okay. Now how to calculate pressure? Or we can say partial pressure, that is equal to mole fraction into total pressure. Mole fraction into total pressure, and mole fraction is number of moles of component divided by total moles into total pressure. So in that way we can calculate the partial pressure. Okay. So let's discuss the question. Let's understand the topic by doing some questions. Okay. So the first, water decomposes at 2300 Kelvin. Like this, we have a H2O gas gives H2 gas and half O2 gas. Okay. So the percent of water decomposes at 2300 Kelvin and 1 bar is. So see, temperature is 2300 Kelvin, pressure is 1 bar, and we have to find out percentage of water decomposing. It means we have to find out alpha, right? We have to find out alpha. And equilibrium constant for the reaction, it is given, and equilibrium constant it is given, that is equal to 2 into 10 to the power minus 3. Okay, so see, देखो, First of all, here pressure is given. Moles, concentration, it is not given, na? So pressure is given. So what I am going to do, I am going to take at the T is equal to 0 पे we have P pressure. Okay, H2 का 0, O2 का 0. Now after some time, or we can say when the time is equal to the T equilibrium, then we have P minus P naught. This is P naught and this is P naught by 2. Because coefficient matters. Here we have coefficient equal to 1, so we write P naught. Here coefficient equal to 1, so P naught. Here coefficient is equal to half, so P naught by 2. Okay, clear? Now fine. Up see, alpha is what? Dissociated amount upon initial amount taken. So if we have alpha, if I'm going to write alpha in terms of pressure, so this is going to be P naught upon P. So P naught is equal to alpha P. Clear? So we can write in that way P minus alpha P. This is alpha P and this is alpha P by 2. Alpha P by 2. ठीक है? So this is P1 minus alpha. This is alpha P. ठीक है? And that one is alpha P by 2. Ab now how to do this? See, now we have another information in the question. We have information pressure is equal to 1 bar. Pressure is equal to 1 bar. You know, total pressure is equal to 1 bar. So we can say PT equilibrium, it is equal to 1 bar. So we have P minus P alpha plus alpha P plus alpha P by 2, it is equal to 1. So cancel out and we get P common 1 plus alpha by 2, it is equal to 1. ठीक है, alpha by 2, it is equal to 1. अब now what we are going to understand कि see, H2O gas है, it is converted to H2 gas and half O2 gas, right? Half O2 gas. So this decomposition, it is actually it's a very slow process. It's a very slow process. So what we can say that 1 upon alpha by 2 को we can take it as 1. Right? We can ignore alpha by 2. We can ignore alpha by 2 with respect to 1. So from here we can say P is equal to 1. Okay? Now, what to do next? Kp. So Kp is what? H2 का pressure, O2 का pressure divided by H2O gas का pressure. So we write alpha P, then we have alpha P by 2 half, and then we have P 1 minus alpha. Clear? 1 minus alpha. So in place of P, in place of V, what we can write? In place of P, what we can write? 1. We can write 1. So here see what we can do. So Kp is equal to, on solving this term, or pressure है, total pressure है, right? So Kp is equal to, we can write, okay, this is going to be alpha under root alpha, okay, divided by under root 2. 1 minus alpha is also equal to 1. 1 minus alpha is also equal to 1. Okay, so this is alpha under root alpha divided by under root 2. Clarity? Let me rewrite this. Let me rewrite this. So here Kp is equal to alpha under root alpha upon under root 2. Okay, and now let's solve it. Let's solve it. Kp ka value is given to us, that is 2 into 10 to the power minus 3. Right? 2 into 10 to the power minus 3. So this is equal to 2 into 10 to the power minus 3. So let's solve this question. So we get alpha 3 by 2, it is equal to 2 की power 3 by 2 into 10 to the power minus 3. Right? Okay. 2 की power this 10 to the power minus 3. अब now how to solve this question? So see, alpha 3 by 2 को let me multiply this by 2 by 3. So here 2 3 by 2 into 2 by 3. And here 10 to the power minus 3 into 2 by 3. So on solving we get alpha equal to 2 into 10 to the power minus 2. अब now percentage is equal to 2 into 10 to the power minus 2 into 100. So it means alpha ka value is equal to 2%. right? Percentage, because we have to write the percent of water decomposing. So answer is 2. Clear? Understood how to solve this question? That is the way. Now let's discuss next type of question. Let's discuss next. So we have, for the reaction SO2 gas plus half O2 gas, it is converted to SO3 gas. Perfect. We have what? SO2 gas plus half O2 gas, and it is converted to SO3 gas. Kp is equal to 2 into 10 to the power 12, and temperature is 27 plus 273. We have to take temperature in Kelvin always. So that is equal to 300 Kelvin. Pressure is equal to 1 atm. So we have to find out Kc for the same reaction is, and we answer is going to be like x into 10 to the power 13, है ना? So we have to find out the value for x. So how to solve this? So see, Kp is given, Kc we have to find out, temperature is given, and R ka value is also given. So we have this relation na, Kp is equal to Kc RT ka power delta Ng. So we have to use this. So delta Ng over here is 1 minus 1 plus 1 by 2, which is 1 minus 3 by 2, and which is equal to minus half. Okay, so we have to find out Kc, which is Kp upon RT ka power minus half, which we can write as Kp into RT ka power plus half. Okay, now we have to put all the values. So Kp is what? 2 into 10 to the power 12. So Kp is 2 into 10 to the power 12. R is 0.082. Temperature is 300, and that is half. Okay, so on solving, we get this equal to 24.6 half. So what I am going to do, I can take it as 25 for easy calculation. So 2 into 10 to the power 12 hai. So under root 25 ka under root we get half, sorry 5, and on solving we get 10 into 10 to the power 12, which is equal to 1 into 10 to the power 13. 1 into 10 to the power 13. Otherwise, you get answer 0.99, right? 0.99 into 10 to the power 13, which you can round it off to 1 only. When we are going to use this kind of approximation, when we have to report the answer in nearest integer, so you can do this thing, right? But if you want to have the exact answer, then there is no need to do the approximation. There is no need to take the approximation. You have to solve completely. Okay. So answer is what? Answer is 1. Okay. Answer is 1. Now, next question. Okay. So we have X gas. It is converted to Y gas and Z gas. And Kp1 is given 3. And we have A gas. It gives 2B gas and Kp2 is equal to 1. Question says, if the degree of dissociation and initial concentration of both the reactants X and A are equal, यानी degree of dissociation is same. Degree of dissociation means alpha same है, and initial concentration is also same. Then the ratio of total pressure we have to find out, P1 and P2. Total pressure, यानी P1 total pressure at equilibrium for this reaction is P1, and for this reaction it is P2. अब see, we have to find out total pressure. So what I am going to do, I am going to find out I am going to write everything with respect to pressure. So degree of dissociation is same. So first of all, to see what we can do. Ki suppose we have a mole of this. So similarly, we have a mole of this. The starting में 0 0, t is equal to 0, and this is also t is equal to 0. T is equal to t equilibrium पे we can write a minus x. This is x. This is x. Right. अब now total moles a minus x plus x, that is equal to a plus x. So pressure at equilibrium, how to write pressure at equilibrium over here? Moles divided by total moles into total pressure, which is P1. X moles divided by total mole a plus x into total pressure P1. C1 x upon a plus x into P1. ठीक है? Now let's write for the second reaction. So second reaction is this, bete. This is the second reaction. So let's write it for this one. So starting A 0 0, मतलब ओनली जीरो है, ओनली जीरो, राइट. Now t is equal to t equilibrium. What is a minus x and this is 2x. Why 2? Because the coefficient is 2. Coefficient is 2. अब now we have to find out the total moles, which is a minus x plus 2x, which is equal to a plus x beta. Now let's find out the pressure at equilibrium. So pressure at equilibrium is moles divided by total moles into total pressure, which is P2. Similarly, for B21, we have 2x upon A plus x into P2. Right? We have to find out P1 upon P2. So, देखो how to do this. We know the value of Kp1 and Kp2. ठीक है? So, Kp1, how to write Kp1? Product का pressure divided by reactant pressure. So, product pressure. See, product pressure x upon a plus x into P1, x upon a plus x into P1 divided by a minus x upon a plus x into P1. Let me write this. So we have x upon a plus x into P1, x upon a plus x into P1, Kp1 I am writing, and here we write a minus x upon a plus x into P1. Now Kp2, so we have to write from here. So 2x upon a plus x into P2 का square, because coefficient is 2. So we have 2x upon a plus x का into P2 का square, and here we have only a minus x upon a plus x into P2. ठीक है, a minus x and a plus x into P2. Now let's simplify this. So when you simplify this, so you can cancel a plus s, a plus x, right? A plus x you can cancel. You can cancel P1, right? P1 you can cancel. So see how to solve this. Now we have x square P1 upon a plus x, a minus x. ठीक है, a plus x, a minus x. Then what you can do, यहाँ पे देखें, on simplify we can write a minus x P2 upon a plus x. This is 4x square P2 square, and here we write a plus x का whole square. Clear? So see, अब now on further simplification what we can do? On further simplification what we can do? See, on further simplification what we can do? I am cancelling everything. ठीक है? So a plus x cancel, a minus x cancel, P2 cancel. ठीक है, x square cancel. So on solving everything we get P1 upon 4 P2. Kp1 is 3 and Kp2 is 1. So this is equal to 3 upon 1. So P1 upon P2 is equal to 12. Right? The ratio is 12 is to 1. P1 upon P2 is equal to 12. Clear? P1 and P2 is equal to 12. The answer is 12 is to 1. Clear? That's it. Now let's discuss next question. So question says, for a concentrated solution of weak electrolyte, we have weak electrolyte A2B3. So A2B3 weak electrolyte hai, so we can dissociate into 2A3 plus and 3B2 minus. How to solve this? How to write this equation? Ax by, it is converted to xa plus y and yb minus x. ठीक है? So of concentration C and the degree of dissociation alpha. So T is equal to 0 पे C 0 0 and T is equal to T equilibrium C minus C alpha. Here we write 2C alpha and here we write C alpha, 3C alpha, right? Okay, now, okay, so we have to find out what K equilibrium. So K equilibrium, how to write? 2C alpha square 3C alpha cube upon C minus C alpha. Okay, अब now when you solve it completely ना, तो you get alpha 5 is equal to alpha की power 5 is equal to K equilibrium upon 108 C4. ठीक है, 108 C4. ठीक है, तो ये आएगा and alpha is equal to K equilibrium 108 C power 4, then power is 1/5. ठीक है, So you get answer equal to option number 2. Okay, ठीक है. Now let's discuss next question. So next question says the equilibrium composition for the reaction PCl3, this PCl3 plus Cl2 gives PCl5. So question says PCl3 at equilibrium it is 0.2 mole, Cl2 equilibrium 0.1 mole and PCl5 equilibrium 0.40 mole. ठीक है. Kc is given 20. अब question says if you add 0.2 mole of Cl2, if you add 0.2 mole of Cl2, then what happens? होगा क्या? What happens? You increase the concentration of Cl2, and if you increase the concentration of Cl2, then reaction moves in the forward direction, right or wrong? Right? If you increase concentration of reactant, then reaction moves in the forward direction. Okay. So it means now we have 0.2 mole of Cl2 is added. So here we have 0.3. Now what happened? System will re-establish the equilibrium. So what happens? Here we write 0.2 minus x, here we write 0.3 minus x, and here we write 0.4 plus x. Clear? Now let's solve it. We have to find out what equilibrium concentration of PCl5. We have to find out equilibrium concentration of PCl5 and we have to report the answer in terms of 10 to the power minus 2. Okay, so see how to solve. Kc is equal to PCl5 concentration divided by PCl3 concentration, which is Cl2 concentration, right? It is equal to 20 because Kc is 20. So PCl5 is 0.4 plus x, this is 0.2 minus x, and this is 0.3 minus x. Okay, so that is equal to 20. Now you have to solve it, you have to simplify it. So once you simplify it, you get 20x square minus ये 10x होगा plus 1.2 होगा, it is equal to 0.4 plus x. On further solving, you get 20x square minus 11x plus 0.8 is equal to 0. Now you have to use x minus b plus minus under root b square minus 4ac upon 2a. Right? When you use this formula, you get two values of x. One is 0.463 and second value is 0.086. ठीक है? So 0.463 is not possible. Why? Because देखो, we have 0.2 and 0.3. So x cannot be greater than 0.2 or 0.3, right? So that's why we have to accept this value. So once you accept x ka value as this, so PCl5 concentration is going to be 0.4 plus x, which is equal to 0.4 plus 0.086, which is 0.486. We have to report the answer in terms of 48.6 into 10 to the power minus 2. So answer is this. Answer is this. Right? If we have to report the answer in nearest integer, so in nearest integer it is going to be 49. Okay, it is going to be 49. But we have the options for this question, so answer is this. Okay, that's it. Now let's do the next question. Consider the reaction N2O4 gas, it gives 2NO2 gas, right? N2O4 gas, it gives 2NO2 gas. N2O4 gas gives 2NO2 gas. So beta Kc is given 20.4, Kp is given 600.1. So you have to find out temperature at which Kc and Kp is this. R ka value you have to take at 0.0831. So how to do this? We know that Kp is equal to Kc RT ka power delta Ng. Okay. So delta Ng for this one is 2 minus 1, which is equal to 1. So it means Kp is equal to Kc RT. So temperature is Kp upon Kcr. Kp is 600.1, Kc is 20.4 and R is 0.083. So once you solve it, you get 353.9 Kelvin. 353.9 Kelvin. So we have to report the answer in nearest integer. So answer is going to be 354. Answer is going to be 354. Now let's do next question. In a chemical reaction, in a chemical reaction A plus 2B, it gives 2C plus D. So initial concentration of B was 1.1 okay 5 times of the concentration of A. So T is equal to 0 पे if concentration of A is C, then B का concentration is 1.5 C. But the equilibrium concentration of A and B were found to be equal, and we have to find the equilibrium constant. Okay, so let's do this. So see, T is equal to T equilibrium पे we write C minus A, okay, C minus X or 1.5 C minus 2X. Here 2C का we write 2X and D का we write X. Now, if I'm going to write with respect to alpha terms, right, with respect to alpha term, so how to solve this question? Okay, so what we are going to do over here, do not write in terms of alpha. Here we have one more information that equilibrium concentration of A and B, they are found to be equal. So what we can write? We can write C minus X is equal to 1.5 C minus 2X. 1.5 C minus 2X. ठीक है? So on solving we get 0.5 C. 0.5 C is equal to X and C का value is going to be or we can say X का value is 0.5 C. We can write in that way only. So here we can say C minus 0.5 C, which is 0.5 C. Here 1.5 C into 2 into 0.5 C, which is equal to C only, right? And we have 1 C. Here we can say 2 into 0.5 C, again 1 C, and here we write 0.5 C. Now we have to find out K equilibrium. So how to write down K equilibrium? Concentration of C to the power C2, concentration of D divided by concentration of A and concentration of B to the power 2. So let's write everything. So we get C ka square 0.5 C divided by 0.5 C and 1 square. 0.5 C and 1 square है ना, यही होगा 1.5 into this. Okay, this is 2 into 0.5 now. Oh, here we write 0.5. Here we have to write 0.5 C है ना. Here we have to write 0.5 C. Perfect. So here we write 0.5 C का square. ठीक है. So let's cancel out. So once you cancel out, so you are going to get answer equal to 100 upon 25, which is equal to, okay, answer is equal to 4. So option A is the answer. Okay, now let's do next question. For the reaction X plus Y, it gives 2Z. 1 mole of X and 1.5 mole of Y and 0.5 mole of Z were taken in a 1 liter vessel. So we have X plus Y, it is in equilibrium with 2Z. We have T is equal to 0 पे, okay, 1 mole, 1.5 mole and Z equal to 0.5 mole. But they are taken in 1 liter vessel. So it means divided by 1, divided by 1, divided by 1. So that is going to be the concentration, mole per liter. Now at T is equal to T equilibrium, what do we write? 1 minus X, 1.5 minus X, and this is equal to 0.5 plus 2X. Okay, now next information. At equilibrium, the concentration of Z was 1 mole per liter. At equilibrium, the concentration of Z, it was 1 mole per liter. Okay, fine. So Z equilibrium, it is 1 mole per liter, which is 0.5 plus 2X, it is equal to 1. Okay, so from here we can find out the value of X. Yes, we can find out the value of X. So 2X is equal to 0.5 and X is equal to 0.5 divided by 2, which we can write as 5 by 20 or 1 by 4. Clear? Okay, fine. Now, here we write 1 minus 1 by 4. Here we write 15 by 10 minus 1 by 4. And here though we have 1. Okay. So when you solve this, on solving, what do you get? Concentration of X equilibrium, it is 1 minus 1 by 4, that is equal to 3 by 4. concentration of Y equilibrium, it is equal to 15 by 10, 15 by 10 minus 1 by 4. ठीक है, 15 by 10 minus 1 by 4, so that is going to be the 5 by 4. ठीक है, and concentration of Z equilibrium, it is equal to 1. So let's find out K equilibrium now. K equilibrium. So we have to report the answer in terms of this x by 15, and we have to find out the value for x. So let's do it. So concentration of Z का square, then concentration of x है, and then we have concentration of y. तो यानी 1 upon 3 by 4 into 5 by 4, so we get 16 by 15. So इसको we have to compare with x is equal to 15, which from this we can say x value is equal to, sorry, not 15, x value is equal to 60. Okay, the answer is 60. Answer is 16. Okay, that's it. Now let's do next question. Okay, a homogeneous ideal gas reaction AB2 gas, AB2 gas, it is in equilibrium with A gas and 2B gas, is carried out in a 25 liter flask at 27 degrees Celsius. Okay, volume is 25 liter and temperature is 27 degrees Celsius, which is 27 plus 273 equal to 300 Kelvin. Okay, initial amount of AB2 was 1 mole and the equilibrium pressure was 1.9 atm. Okay, initial amount, it is 1 mole. So A0, B0. T is equal to T equilibrium, we write 1 minus x, x and 2x. Equilibrium pressure, it was given 1.9 atm and value of Kp we have to find out. So it means the task is to find out partial pressure now, है ना? Partial pressure now. So let's find out partial pressure. So pressure at equilibrium, moles divided by total moles. So total moles are equal to 1 minus x plus 2x. So we get 1 plus 2x. Fine. So 1 minus x plus 1 plus 2x into total pressure 1.9. X upon 1 plus 2x into total pressure 1.9. 1.9. Then 2x upon 1 plus 2x and total pressure 1.9. Okay. Next thing. Total pressure. Okay. That is 1.9. Now ठीक है, अब now how to solve this question. तो ठीक है, let's do this. So Kp का value is given, volume is given, it is carried out in a 25 liter flask. ठीक है, fine. अब now the task is to find out total moles, otherwise we are going to have two variables na, because Kp is what? Pressure of A, pressure of B ka power 2 and pressure of AB2. So we have two variables. In pressure terms we have x and Kp we have to find out, right? So it means what we can do, we can use this equation, which equation? PV ka power nRT for total, right? For total, everything total. So pressure is 1.9, volume is 25 liter, total moles and R का value 0.082, 0.082, ठीक है, 0.082 and temperature is what? 300. So on solving we get total number of moles as 1.93. 1.93 is total number of moles. So if we get total moles 1.93, which is equal to 1 plus 2x. Right. So from here we can find out the value of x. So x is going to be 0.465. ठीक है, अब तो we have to put the value, right? So Kp is equal to, see, 2x upon 1 plus 2x, 2x upon 1 plus 2x का square into 1.9 square. Then x upon 1 plus 2x into 1.9 divided by 1 minus x upon 1 plus 2x into 1.9. Now we have everything. We have everything. So see how to solve this. Okay, fine. So let's put all the values from here. So we get 2x का हो जाएगा 0.93. First, let us cancel. Let us cancel. So we can cancel 1 plus 2x, 1 plus 2x, 1.9, 1.9. Okay, we can cancel this. Put every value. You have the value for x. You have the value for 1 plus 2x as 1.93. Okay, you have all these values. 1.9 is there. So when you solve it, you get Kp is equal to 0.73. Now we have to report the answer in terms of 10 to the power minus 2. So that is going to be 73 into 10 to the power minus 2. Okay, so answer is 73. Okay, now let's do the next question. 5.1 gram of ammonium sulfide is introduced in a 3-liter evacuated flask. Okay, ammonium, it's not sulfide, NH4SH. ठीक है, so this is 5.1 gram and it is introduced in 3-liter vessel at 327 degrees Celsius. So 327 plus 273, ठीक है, 327 plus 273, that is equal to 600 Kelvin. Fine. And it decomposed into NH3 and H2S gas. So that's a solid and it decomposed into NH3 gas and H2S gas. The equation is balanced? Yes, the equation is balanced. Okay. Okay. 30% of the solid NH4SH decomposed. Okay. So first we have to find out the moles of NH4SH. So the volume is 3 liter. So molar mass of NH4SH, it is equal to nitrogen का 14, hydrogen 5 into 1 and sulfur 1 into 32. So on solving we get 14 plus 5 plus 32, we get 519. ठीक है, ठीक है, not 519, we get 51 gram. ठीक है, so we get 51 grams. So number of moles 5.1 divided by 51, which is equal to 0.1 mole, which is equal to 0.1 mole. ठीक है, so अब solve करते हैं. Let's solve. NH4SH solid gives NH3 gas plus H2S gas. So we have 0.1 mole, 0, 0. Then equilibrium, we can write 0.1 minus 0.1 alpha, then 0.1 alpha and then 0.1 alpha. ठीक है, 0.1 alpha. ठीक है. Alpha value is given, that is 30%, है ना? Alpha is 30%. So alpha is 30 by 100, which is 0.3, we can say that. Clear? अब now what to do? ठीक है, अब now what to do? So we get 0.1, 1 minus alpha, and here we get 0.1 into 0.3, and here we can say 0.1 into 0.3. ठीक है, 0.1 into 0.3. We have to find out the value for Kp. So let's do this. So 0.1, 1 minus 0.3, 0.1 into 0.3, and this is 0.1 into 0.3. So Kp का value, how to solve? Pressure of NH3 and pressure of H2S. NH4SH ka we are not going to include. Why? Because activity is equal to 1. So there is no need to do all this part. करना ही नहीं, nothing. Right? तो pressure of NH3 क्या हो जाएगा? That is equal to point. अच्छा, pressure निकालना है ना. This is moles. Right? So that is equal to mole. That is equal to moles. Okay, fine. So how to find out the pressure over here? So pressure के लिए what we can use PV is equal to nRT. So PV is equal to nRT. Pressure is equal to how much? What is the pressure over here? We have to find out. Volume is 3 liter. Volume is 3 liter. So number of moles को we can say 0.03 because it is equal to 0.03. R is 0.082, temperature is 600 and volume is 3. So we get 0.492. Okay. And Kp, how to calculate? Pressure of NH3 and pressure of H2S, which is equal to 0.492 into 0.492, and on solving we get answer 0.242. 0.242. Okay, that's it. So answer is 0.242 atm square. So fourth is the correct answer. Now let's do the next question. Consider the reaction N2 gas plus 3H2 gas, right? N2 gas plus 3H2 gas, and it is in equilibrium with the ammonia gas. Okay. So the equilibrium constant of the above reaction is Kp, or we can say this reaction equilibrium constant, it is Kp. If pure ammonia is left to dissociate, okay, the partial pressure of ammonia at equilibrium is given by. So see what we can do with this reaction. So see, suppose if we say that this is P and this is 3P and initially it is 0, right? So now T is equal to T equilibrium. We can say P minus P naught. This is 3P minus 3P naught and this is going to be 2P naught. ठीक है. अब question says कि pressure of NH3 is very less in comparison to the total pressure, है ना? Pressure of NH3, it is very less in comparison to total pressure, right? It means the reaction does not move in the forward direction. No? It doesn't move in the forward direction. So what we can write, कि like P minus P naught, it is actually equal to P. It means we can ignore P, right? We can ignore P, right? So here what we can write, matlab P naught is very less in amount because the reaction doesn't go in that direction, doesn't go in the forward direction. So we can say nitrogen is P, hydrogen is 3P, and here we can say this is going to be the pressure of ammonia, right? जो भी बना होगा थोड़ा बहुत, right? Some amount of ammonia is prepared from this reaction, तो जो भी whatever बना होगा that is equal to pressure of NH3. Okay. Now we have to find out Kp. So how to find out Kp? That is the pressure of NH3 का square upon pressure of N2 and then pressure of H2 का cube. ठीक है, this is small. अच्छा यहाँ पर this, if you see the option ना, here we have total pressure. P is actually total pressure over here, है ना? P is total pressure. So it means we can write total pressure is equal to P minus P naught plus 3P minus 3P naught plus 2P naught. It is equal to capital P, total pressure. So from this we can say 4P minus 4P naught plus 2P naught, it is equal to P, which is 4P minus 2P naught, it is equal to P. Now P naught is less, right? P naught is less in amount. So we can say that कि जो P है, right? P or total pressure, this is P total. I am writing P total over here, right? P total. So P total is equal to 4P. ठीक है, 4P. Right? अब see, pressure of NH3 को we can write P NH3 square. Pressure of N2 को we write small p and इसको we can write 3P का cube. ठीक है. So on solving, we have to find out pressure of NH3. है ना? We have to find out what? The partial pressure of ammonia. The partial pressure of ammonia at equilibrium. ठीक है. So let's do this. So this is going to be Kp P and that is equal to 27P cube, which is Kp or P ka power 4 and this is 27. Okay. Now how to solve this? How to solve this? See, P NH3 is what? Kp ka power half, P ka power 2 and this is 3 ka power 3 by 2. 3 का power 3 by 2, right? Because 27 को तो we can write ना 3 का power cube. So 3 का power 3 by 2. अब now this pressure को if I write in terms of total pressure, तो this is Kp का power half, this is P by 4 total pressure Pt square and this is 3 का power 3 by 2. Okay, 3 का power 3 by 2. Let me write it over here. So we can write Kp का power half P by P total by 4 का square and that is 3 का power 3 by 2. That's it. ठीक है, तो if you relate, this is the answer. If you relate this with the option, you get the answer that is 1. That is equal to 1. Okay, ठीक है. Now let's do next type of question. In this we are going to discuss the thermodynamics of equilibrium. So we have discussed these type of questions in thermodynamics also. So here we have to use this formula ki like we know that ki bhai thermodynamics of equilibrium means we have to understand the spontaneity of reaction, that is by the Gibbs free energy. So at equilibrium, we know that delta G is equal to 0. So we have delta G is equal to delta G naught plus RT ln K equilibrium. So 0 है तो delta G naught plus RT ln K equilibrium, or we can say that कि delta G naught is equal to minus RT ln K equilibrium, or we have minus 2.303 RT log K equilibrium. Okay. Also, we have one formula, one more formula, that is delta G is equal to delta H minus T delta S. And under standard condition, we can write delta G naught is equal to delta H naught minus T delta S naught. So generally, we are going to use these two formulas in order to solve the below questions. Okay. So let's start solving questions. Okay, so the first is for independent process at 300 Kelvin, A, B, C, D, the number of non-spontaneous process from the following is. So in order to calculate non-spontaneous process, we have to find out delta G, na, delta G. So delta G is what? Delta H minus T delta S. So see, for the first case, for option number 1, delta H is negative and delta S is negative. So delta H is negative, which is in kilojoule per mole. So delta G is equal to minus 25,000 minus T. Temperature is 300. So we write 300 and this is minus 80. So we get minus 25,000 and 8 3s are 24. So this is plus 24,000. So overall it is going to be negative. So process A is spontaneous. ठीक है, process A is spontaneous. Now check for option number B. तो option number B, delta H is negative, which is minus 22 into 10 to the power 3 joule per mole, and delta S is positive, which is 40 joule per Kelvin. ठीक है, 40 joule per Kelvin. So delta G is equal to delta H minus T delta S. So this term is negative, delta S is positive. So overall value is going to be negative. So there is no need to find out the value. So B is also spontaneous. B is also spontaneous. Now let's check for option number 3. So we have delta H 25, delta S minus 50. Delta H 25 and delta S minus 50, right? Okay. 25 into 10 to the power 3 joules में. That is in joule per mole and this is in joule per Kelvin. ठीक है. तो delta G is equal to delta H minus T delta S. So that is 25,000 minus 300 and minus 50. So which is equal to 25,000 and 5 3s are 15. So plus 15,000. So that is going to be positive. So reaction is non-spontaneous. So the third process is non-spontaneous. Now check for D. So in order to check D, delta H is 20 and delta S is 20. Delta H is 20 into 10 to the power 3 and delta S is also 20. 20 है ना? Yeah, 22. Delta H is 22, not 20. 22. So delta G is equal to 22,000 minus 300 into 20, which is 22,000 minus 3 2s are 6. ठीक है? 3 2s are 6. So that overall term is going to be positive. ठीक है? Overall term it is going to be positive. So we have to find out non-spontaneous process. So non-spontaneous process, we have this is non-spontaneous process and this is also non-spontaneous process. ठीक है, please check my calculation. We have to do in that way. So by doing this, so number of spontaneous non-spontaneous process they are going to be, ठीक है, clear? That's it. That's it. Negative. C is non-spontaneous. A and B, they are spontaneous. Okay, fine. A is spontaneous. Okay, that's it. Okay. Now let's check for this. Consider the following reaction approaching equilibrium at 27 degrees Celsius and 1 atm pressure. So, okay, we have A plus B and Kf is 10 to the power 3 and K reverse is 10 to the power 2 and we get C plus D. Fine. So we have to find out standard Gibbs free energy. So which formula we have to use? Delta G naught is equal to minus 2.303 RT log K equilibrium. अब now first we have to find out K equilibrium. So K equilibrium is equal to Kf upon Kb, which is 10 to the power 3 upon 10 to the power 2, 10. Right, so we get minus 2.303. R का value, if I want to find out in kilojoule, so we write 8.314 divided by 1000. Temperature is 27, so 27 plus 273, 300. So 300 and log 10. Log 10 is equal to 1. So it means we have to solve 2.303 into 8.314 into 300 divided by 1000. ठीक है, so on solving we get 5.744. ठीक है, we have to report in nearest integer, so answer is going to be 6. That's it. Okay, now next question. For the reaction A gas and it gives B gas. So the value of equilibrium constant at 300 Kelvin and 1 atm pressure is equal to 100. So K equilibrium is 100. The value of delta G reaction, okay, is minus XR. So we have to find out the value of X. So we have to find out the value of X. So which formula we are going to use? We are going to use delta G naught minus. Acha, here information is given कि ln 10 को we have to take 2.3. So there is no need to write 2.303. So we write minus 2.3 RT log K equilibrium. So minus 2.3 R, temperature is 300 Kelvin and log 100. Log 100 ko we can write 2.3 R into 300 into log 10 to the power 2, which we can write as into 300 into 2 log 10, and log 10 is equal to 1. Log 10 is equal to 1. So we have answered 2.3 into 300 into 2 R. Okay. So on solving we get minus 1380 R. Okay. So here answer is 1380. Okay. Now let's do the next question. For the reaction A gas and B gas at 495 Kelvin, delta G naught is given. Okay, fine. If we start the reaction in a closed container at 495 Kelvin with 22 millimoles of A, then amount of B in the equilibrium mixture. So this is 0, T is equal to 0. Then T is equal to T equilibrium, 22 minus X, and this is X. Okay, that is going to be millimole, and this is millimole. We can also find out the concentration. So concentration में 22 minus X upon V and here X upon V. ठीक है. So first step is to find out log K equilibrium. अच्छा, log K equilibrium. How to find out log K equilibrium? By using this formula. Which formula? Delta G naught is equal to minus RT ln K equilibrium. So we can write log K equilibrium or delta G naught is minus 2.303 RT log K equilibrium बेटा. ठीक है. So log K equilibrium is equal to we have to put all the values, है ना, we have to put all the values. So that is in kilojoule. So we can say 9.4 minus 9.478 into 1000 divided by minus 2.303 into R का value we have to take 8.314 and temperature is 495. Okay. So when you solve this na, so log K equilibrium, it is going to be 9478 and denominator term comes out to be 9477.8, which you can take as 9478. So log K equilibrium is 1. So K equilibrium is what? Antilog of 1. Antilog of 1 means 10 to the power 1. 10 to the power 1. So first we have to find out log K equilibrium. Up now K equilibrium is what? Concentration of B at equilibrium divided by concentration of A at equilibrium, because we have this. Okay. So on solving further, we get 10 is equal to x upon V upon 22 minus x upon V. Right? 22 minus x upon V. So we get 220 minus 10x is equal to x. Okay. So 11x is equal to 220 और x का value comes out to be 20. ठीक है. So in the question we have to find out the amount of B. So here answer is 20 millimoles. Clear? That's it. Now let's solve next question. The gas phase reaction to a gas gives A2 gas, right? Temperature is 400 Kelvin. Delta G naught is plus 25.2 into 10 to the power 3 joule per mole. And we have to find out the equilibrium constant Kc. See, we have one formula. Delta G naught is minus RT ln K equilibrium. Okay. Everything over here is in gaseous state. So here K equilibrium is going to be Kp. Or we can say delta G naught is ln 10 is 2.3. So we can say minus 2.3 RT log Kp. ठीक है. So we can find out the value of Kp over here. So delta G naught is 25.2 into 1000 divided by 2.3. R का value is 8.3 and temperature is 400 Kelvin. Temperature is 400 Kelvin. So on solving log Kp का value, right? Log Kp का value is minus 3.3. Minus 3.3. So Kp is minus anti-log of 3.3. So anti-log of 3.3, how to calculate? We have to split the term. Minus 3 minus 0.3. This minus 3, it goes to the 10 to the power. So we can say this is going to be anti-log of minus 0.3 into 10 to the power minus 3. So anti-log of minus 0.3, it is given 0.501. Okay. So Kp का value is 0.501 into 10 to the power minus 3, which we can write as 5.01 into 10 to the power minus 4. That is going to be bar. ठीक है. Or we can say bar inverse. ठीक है. Up now we have to find out Kc. So we know that Kp is equal to Kc RT का power delta Ng. Delta Ng dimer है तो 2A gas, it gives A2 gas. So delta Ng from here it is going to be 1 minus 2, which is minus 1. So Kc is equal to Kp upon RT to the power minus 1, which is Kp into R into T to the power 1. Okay. So Kp is 5.01 into 10 to the power minus 4. R का value we have to take 0.082 because bar में pressure Kp है. Temperature is 400. So when you solve this, you get 1.64 into 10 to the power minus 2, or we can report the answer in terms of 2 because round off to the nearest integer. So answer is going to be the 2. 2 into 10 to the power minus 2. And here we can write answer as 2. Clear? Now let's do the next question. For the equilibrium, 2H2O gives H2O positive and OH minus. See, this is what? Autoprotolysis of water, and here K equilibrium is basically equal to Kw, which is H3O positive and OH minus, है ना? And Kw value is 10 to the power minus 14 and pKw is value is minus log of 10 to the power minus 14, which is going to be plus 14. ठीक है, pKw value is 14. So we have to find out the delta G naught. So delta G naught is what? Minus RT ln Kw, or we can say minus 2.303 RT log Kw. So see, minus log of Kw, it is actually equal to pKw, right? अब now तो you have to put values. So 2.303, R का value you have to take 8.314, temperature is 298, pKw is 14. We have to find out the answer in kilojoules, right? So divided by 1000. R का value 8.314 है, that is in joule. We want answer in kilojoule, so divide by 1000. So when you solve this, you get answer equal to minus 79.88 kilojoule per mole, which you can write as minus 80 kilojoule per mole. So option 2 is the correct answer. Option 2 is the correct answer. Now let's discuss next type of problem, in which we are going to discuss questions which is related to the factors affecting equilibrium constant. So factors affecting equilibrium constant means कि देखो, first factor which affects the equilibrium constant is the stoichiometry of the reaction. Stoichiometry of the reaction. Stoichiometry of reaction. So see, if we have some reaction A, or we can say simply reaction A plus B, and it gives C plus D. ठीक है, and suppose K equilibrium for this reaction is K1. Okay, K equilibrium for this reaction, it is K1. If I'm going to multiply, ठीक है, multiply by 3 with the whole equation, so we get 3A plus 3B, it is in equilibrium with 3C plus 3D. So here K equilibrium is equal to K1 की power 3. Okay, then if I multiply the whole equation by 1 by 3, so we get 1 by 3A plus 1 by 3B. It is in equilibrium with 1 by 3C and 1 by 3D. So here K equilibrium, it is equal to K1 ka power 1 by 3. Understood? K equilibrium, it is equal to K1 ka power 1 by 3. Now, addition of two reactions, if you add reactions, addition of two reactions, then K equilibrium is going to be K1 into K2. You have to multiply the equilibrium constant. If you subtract two reactions, subtraction of two reactions, then you have to divide equilibrium constant. Okay, that's it. Now let's solve the question of this type. We have at 298 Kelvin, we have this equation 1, this is equation 2, and this is equation number 3. Based on the above equilibrium, the equilibrium constant of this reaction. So this is the desired reaction. So how to solve this question? So see, bete, we need ammonia on left hand side. We need ammonia on left hand side. But in first question, we have ammonia on right hand side, right? So what I'm going to do, I'm going to reverse equation 1. On reversing equation 1, right, if you reverse the equation, then we have to take the reciprocal of the equilibrium constant. So we have 1 by K1. Okay, we can do this thing. Now coefficient of ammonia over here is 2, here also 2. Okay, then we have 2NO on right hand side, and in the second equation 2NO on the right hand side. So kuch nahi karna, we have to add equation 2. Okay, plus add equation 2. If I'm adding equation 2, so equilibrium constant we have to multiply, so into K2. Next, we need water, 3 water molecules on right hand side. In the third equation, we have 3 water molecules on right hand side, but we have to multiply, right? Add equation 3, but before adding, multiply by 3. Multiply by 3. ठीक है, तो overall K equilibrium is going to be K1, 1 by K1 into K2, and then K reverse भी करना है ना, we have to reverse, नहीं, not reverse, third equation को no reverse, it's just this, K3 का power 3 because multiply किया. That's it. You get the same equation. Let's prove it. Let's prove it for you. 2NH3 है, so reverse. On reversing we get 2NH3. It gives N2 gas plus 3H2 gas. Second equation as it is. N2 gas plus O2 gas. It is in equilibrium with 2NO gas. Third equation as it is, but we have to multiply by 3. Multiply the equation with 3. So 3 by 2 O2 and it gives 3H2O. ठीक है? Now simplify. Let's simplify or add. Let's add these reactions. So see, 3H2, 3H2 cancel bete. Cancel. N2 gas cancel. अब now if you add all reaction, you get the desired equation. ठीक है? So it means K equilibrium is 1 by K1 into K2 into K3 की power 3. So 1 by K1 into K2 into K3 का power 3. All equilibrium constants are given in the question. K1 is 4 into 10 to the power 5. So write 1 upon 4 into 10 to the power 5. K2 is what? 1.6 into 10 to the power 12. So write this. K3 is what? 1 into 10 to the power minus 13. So 1 into 10 to the power minus 13, it's ka cube. So on solving, when you solve this completely, you get answer equal to 4 into 10 to the power minus 33. Okay. So answer is dash into 10 to the power minus 33. So answer is equal to 4. Okay. Now let's do the next question. If the equilibrium constant for A gives B plus C, it is K equilibrium 1. And for B plus C, it gives P. For this K equilibrium 2. Now equilibrium constant for A to P. A to P. So for A to P, what happens? Cancel out. Let's cancel this one. B, C cancel. So A to P. It means you have to add these two reactions, na? So K equilibrium for this one is going to be K equilibrium 1 and K equilibrium 2. On addition, you have to multiply the equilibrium constants, right? So answer is going to be 4th. That's it. Let's do next question. We have considered the following reversible chemical reactions. So we have A2 gas, B2 gas gives 2AB and we have this. So question says relationship between K1 and K2. So see, 2AB hai and in K, matlab in second reaction we have AB on the left hand side. So what we are going to do, reverse equation 1. So on reversing equation 1, the equilibrium constant is going to be 1 by K1 reciprocal. Now you have to multiply equation with 3, reverse and then multiply by 3 and then multiply by 3. So if you multiply by 3, so you get the second equation. So if you multiply by 3, the equilibrium constant 1 by K1 to the power 3. So that is equal to the equilibrium constant for the second reaction. So what we can write? What we can write? We can write K2 is equal to K1 का power minus 3. ठीक है? K2 is equal to K1 का power minus 3. देखो prove कर लेते ना. Let's prove it. Reverse first equation. So we have 2AB gives A2 plus B2. Now multiply this with 3. So we get 6AB 3A2 plus 3B2. है ना? Same thing. Once you reverse it, so 1 by K1 and when you multiply with 3 to 1 by K1 ka power 3. That is equal to the value of K2. Okay, fine. Let's do the next question. This is also based on this thing. Just try at home. Just try at home. Answer is going to be 3, 10 to the power 25. Same question, same way. Same way say you have to solve. Okay, now this question, the stepwise formation of this is given below, stepwise. And we have the stability constant K1, K2, K3 and K4 for the respective reactions. So the overall equilibrium constant karna hai for the dissociation of this one. So see, this is equation 1, this is equation 2, this is equation 3 and this is equation 4. If you add 1, 2, 3 and 4. So you get C2 plus 4NH3 and that gives K CuNH3 2 positive, right? You get this one. ठीक है, and if you add, so it means k is equal to k1 into k2 into k3 into k4. Okay, but the question says the overall equilibrium constant for dissociation. Dissociation means you have to reverse this reaction na, you have to reverse this reaction. So yani CuNH3 2 positive, it is in equilibrium with Cu2 plus 4NH3. Up you have to find out for this one, na. So for this one, k dash is equal to 1 by k. 1 by k is just, now you have to solve, right? You have to solve values of k1, k2, k3 and k4, they are given to you. ठीक है, when you solve this ना completely, so you get 12.6 into 10 to the power minus 12. ठीक है, so x का value is, इसको you have to compare with x into 10 to the power minus 12. So x का value is 12.6 and in nearest integer it is going to be the 30. It is going to be the 30. Okay, now let's do next type of question, which is based on Le-chatilier principle, right? So what is Le-chatilier principle? If you disturb the equilibrium somehow, then system tries to adjust in such a manner so that that change can be nullified, right? So it means system is going to re-establish the equilibrium somehow. So what happens, suppose if you increase the concentration of reactant, if I'm saying concentration of reactant increases, then system goes in forward direction in order to decrease the concentration of reactant. So system moves in forward direction. ठीक है, if concentration of product decreases, concentration of product decreases, so it means system moves in forward direction in order to make the product, right? Because system is going to nullify the change. Similarly, if concentration of reactant decreases and concentration of product increases, then reaction moves in the backward direction. Next, if you increase the pressure, then what happens? System is going to decrease the pressure. ठीक है, तो when you increase the pressure, तो we can also memorize in that way, on increasing the pressure volume decreases, and we know that volume is directly proportional to number of moles. So system, or we can say equilibrium, shifts to that direction where number of gaseous moles are less. Okay, then we have, if you decrease pressure, so it means volume increases na. So equilibrium shifts to that direction where number of gaseous moles are more. Because if we have more number of gases, right, then more collision and more pressure. If you decrease the pressure, then system is going to increase the pressure. Okay. Now we have, if you increase the temperature, so if you increase the temperature, then exothermic reactions are favorable. Exothermic reactions are not exothermic. Basically, if you increase the temperature, so endothermic reactions are favorable. Endothermic reactions are favorable. Okay. Now, if you decrease the temperature, then exothermic reactions are favorable. Exothermic reactions are favorable. Okay. Now, last concept over here, inert gas addition. So, inert gas addition. So, if inert gas is added at constant volume, then no change. No change. कुछ नहीं होगा. If you add inert gas at constant pressure, so on adding inert gas, volume increases. And if volume increases, then equilibrium shifts to that direction where more moles हैं, more moles of gases. Clear? More moles of gases. That's it. So we have to use these concepts in order to solve the upcoming question. So let's do this question. Consider the following equation. We have equation this 2SO2 gas plus O2 gas. It is in 2SO3 gas. ठीक है. So delta H over here is minus 190 kilojoule. It means reaction is exothermic. Okay. If reaction is exothermic, then low temperature. If the temperature is less, then the reaction moves in the forward direction. ठीक है. Now, the number of factors which will increase the yield of SO3. Increase the yield of SO3 means reaction should move in the forward direction. Huh? It should move in the forward direction. So, increasing temperature? No. Increasing pressure? We have to check. Adding more SO2? If you add more SO2 or more O2, then from this reactant concentration increases, and if reactant concentration increases, then it will move in the forward direction. So C and D, yes. Addition of catalyst, no. Addition of catalyst just increases the rate of a reaction, not increase the amount of SO3. So here, no. Now we have to check for increasing pressure. So beta, if you increase pressure, so what I told you, what is the trick? If you increase the pressure, then volume decreases. And we know that volume is directly proportional to number of moles. Then equilibrium shifts to that direction, where gaseous moles are less. So see, in the reactant side we have 3 mole and in product side we have 2 mole, right? In product side we have 2 mole. So yes, equilibrium will shift in the forward direction. So total number of factors which will increase yield of SO3, that is equal to 3. Answer is 3. Answer is 3. Okay. Now let's do next question. The effect of addition of helium gas to the following reaction in equilibrium state. Addition of helium gas, it means inert gas. जैसे PCl5 gas, it is in equilibrium with PCl3 gas plus Cl2 gas. ठीक है. अच्छा देखो, this is given. अब now reaction है ना, तो I am taking like कि volume is fixed, क्योंकि nothing is mentioned ना. Volume is fixed, nothing is mentioned. क्यों? देखो, if the volume is constant, then addition of the inert gas does not change the equilibrium, does not affect the equilibrium. If volume is not constant, and if volume is not constant, it means by the addition of inert gas, you can increase the volume of the container. Then what happens? Reaction moves in that direction where we have more number of moles. Now here nothing is given, so I am taking the volume is fixed. So if volume is fixed, then what happens? The addition of helium will not affect the equilibrium. So I am marking the answer number 4, option number 4. Okay. Now let's do next question. Consider the following reaction, which is N2O4 gas and it is in equilibrium with 2NO2 gas. Delta H naught is plus 58 kilojoule. It means it's an endothermic process and it is favorable at high temperature. So ठीक है भाई. So question says, for which of the following cases 1 and 2 the direction in which equilibrium shifts is? So if you decrease the temperature, here reaction is favorable at high temperature. So if you decrease the temperature, then what happens? Reaction moves in the backward direction. Backward direction means towards reactant, है ना? Backward direction means towards reactant. Second, pressure is increased by adding nitrogen at constant temperature. Pressure is increased by adding nitrogen at constant temperature. अब नाइट्रोजन क्या है? इनर्ट गैस है ना, इनर्ट गैस. इट मीन्स यू आर इंक्रीजिंग द प्रेशर. ठीक है. अब इनर्ट गैस का एडिशन है एट कांस्टेंट टेम्परेचर है, तो वी कैन से नो चेंज. अंडरस्टूड? तो नाइट्रोजन है ना, क्या करेगा? नथिंग, इट विल डू नथिंग. ठीक है. रिएक्शन में इट डज नॉट पार्टिसिपेट विद द रिएक्शन. क्लैरिटी? तो वी कैन से टुवर्ड्स रिएक्टेंट एंड नो चेंज. क्लियर? ठीक है. So if you are increasing the pressure, means we can say this thing na, if you are increasing the pressure, then volume it is going to be constant, and at constant volume addition of inert gas does not affect the equilibrium. So answer is 3. Okay. Now we are moving to the last type of the problem, that is based on the simultaneous equilibrium. ठीक है. So simultaneous equilibrium means ki we are having two reactions, and in the two reaction one of the product is going to be common. One of the product is going to be common. Just for example, we have A plus B. It is in equilibrium with C plus D. As if we have E plus F and it is in equilibrium with C plus G. So here C is going to be common, na? So it means simultaneous equilibrium, right? So we have these type of reactions. So let's see how to solve this type of question. So see, first is A solid. It is in equilibrium with B gas, C gas, and here Kp1 is equal to X. And we have D solid, it is in equilibrium with C gas and E gas, and here Kp2 is equal to Y. ठीक है, अब see the total pressure when both solids dissociate simultaneously. So total pressure, it is equal to pressure of B, pressure of C and pressure of E, because they are in gaseous state. ठीक है, right? अब now ठीक है, so how to solve this question? तो see, solid का तो we are not going to consider, तो T is equal to T equilibrium पे we are writing B का pressure as P1 and C1 का pressure is also P1. Now here T is equal to T equilibrium पे C1 का pressure as P2 for the second one and E का pressure as P2. अब now C is in same container ना, तो here it is not P1, it is equal to P1 P2, and here it is not P2, it is equal to P1 plus P2. Clarity, but that's a concept. Now we have to use like Kp1, which is equal to X, which is pressure of B and pressure of C. So X is equal to P1 and P1 plus P2. ऐसे similarly Kp2, it is equal to Y, which is equal to P2 and P1 plus P2. See, P2 and P1 plus P2. ठीक है, now let's add these two reactions. So if I add these two reactions, तो X plus Y, it gives P1 plus P2 का whole square, and P1 plus P2 is going to be under root X plus Y, right or wrong? Under root X plus Y. ठीक है, अब now if I want to find total pressure, so PB is what? P1, PC is P1 plus P2, and PE is P2. So we can say 2 P1 plus P2, right? P1 plus P2 का value is under root X plus Y. So we can write 2 under root X plus Y. Clear? 2 under root X plus Y. That's it. Is it clear? So answer is going to be option number 2. Okay, so that's it. So that is the last question for the chemical equilibrium. I hope you understood the chapter well. I hope you understood the questions very well. If you like this video, then you can drop a comment in the comment section, and you can even join the PracBee Revision Program, which is the 10-week program in which we are going to discuss the concepts of the topics and the previous year questions, so that you can have the better clarity of the concepts. Okay, the PracBee Revision Program details, that is in the description box, so you can find all the details in the description box. You can also connect with us if you drop a comment, right? That's it. So see you in the next video. In the next video we are going to discuss some previous year questions of ionic equilibrium. Okay, bye, take care.